After being discovered in 1930, Pluto has been a permanent member of our planetary system for more than 75 years. However, in 2006, the International Astronomical Union decided to rethink the official definition of a planet after discovering more and more Pluto-like objects in the Kuiper Belt. As a result, Pluto was placed in the newly opened ranks of dwarf planets, of which it is now the largest known representative. Given the decades-long history of research and the major controversy surrounding Pluto, it seems even more astounding that for a long time there were only blurry images of the distant celestial body, making it impossible to gain a detailed understanding of this distant world. On January 19, 2006, NASA's New Horizons probe visited the dwarf planet's far-off realms. Therefore, the transmission of the data that the unmanned spacecraft collected over Pluto during this time terminated on October 25, 2016, allowing for the first close-up analysis of Pluto. Since that time, the New Horizons' primary mission has ended, and the next time a spacecraft will depart for the dwarf planet is currently only indicated by the stars. As a result, the amazing photos captured by the mission's technical equipment are the last images of the former planet for an indefinite amount of time. Today, let's examine the intriguing photos and discoveries that New Horizons took and made. Public. If you're interested in regularly learning more about the groundbreaking discoveries and unique sights in the cosmos, don't forget to subscribe to Simply Space and click the bell. By giving us a thumbs up, you're encouraging us and demonstrating that we can keep you interested in the post's content. Overseas music. A brief synopsis of Pluto. We must first address the fundamental question of what constitutes a planet under the present definition of the IAU, which states that a celestial body must meet 3 criteria in order to be included. In the corresponding rankings, in order to comprehend why Pluto was excluded from our local planetary system. With an equatorial diameter of 1475 miles, Pluto's planetary end was sealed at this final point. Its orbit must lead it around the Sun, have a roughly spherical shape, and be the dominant celestial body in its orbit. That is, it must have cleared this orbit from other objects using its gravitational field. The dwarf planet is much smaller than the moon of Earth. Our Earth is known to take 365 days to complete its orbit around the Sun, but our constant companion is valued at about 2,159 miles in this category. The dwarf planet travels through space, at a distance of sometimes 49.3 astronomical units from the Sun, whereas Pluto takes more than 247 years to accomplish the same task. Once more, for a quick explanation, the astronomical unit is equivalent to the approximate distance between the Sun and Earth, or roughly 90 million miles, and the celestial body never gets closer than 29.7 AU to our central star. Pluto's location, far from the Sun, contributes to the extremely frigid temperatures that prevail there. On average, the thermometer reads -404 degrees Fahrenheit. We now know that Pluto is not going through space alone. It is accompanied by at least 5 natural satellites. The dwarf planet is comparable to Neptune's moon Triton, with a massive, rocky core followed by a coating of water ice, which is then encircled by nitrogen ice. With an average diameter of roughly 745 miles, the 2 celestial bodies have a double-bound rotation, meaning that they always face the same side. The largest Pluto moon by far is called Charon. Because of these size ratios, scholars have been debating whether it would not make more sense to refer to the double system because Charon is half the size of its cosmic counterpart. Pluto-Charon is located beneath the nitrogen-dominated atmosphere. From massive ice surfaces to the mighty 11,500-foot-high Norgay months to unique reliefs like a snake's skin, the interesting landscape of the dwarf planet welcomes us on an area roughly equivalent to that of the South American continent. Pluto provides us with breathtaking photos that demonstrate the inherent diversity of the cosmos. On July 14, 2015, the time had finally come after a 9-year flight. New Horizons swung into the realms of Pluto, giving us a detailed look at the remote dwarf planetary world for the first time in history during its research mission, the spacecraft. Approached within 700–800 miles of the celestial body, capturing countless high-resolution images of Pluto and its companion Charon. As a result of the immense distance that gaped between the $700 million piece of equipment and Earth, it took more than 15 months to transmit all of the collected data. But it was worth the wait. In the following clips, we would like to present some of the most impressive images that New Horizons has provided for us. First, let's look at the color-enhanced overall view of the dwarf planet, while the image leaves us in pure awe with its overwhelming detail. It is also of unparalleled value to scientists based on the differently colored regions. The experts can understand how their chemical composition is formed accordingly. It can be clearly seen how the right area, the so-called tombo regio, is divided into two distinct regions. This heart-shaped region's left bulge, the Sputnik Planitia, is incredibly smooth. Speaking of Sputnik Polynesia, we are aware that Pluto frequently experiences unusual ice flows because of New Horizons. In addition to the data indicating that the center of Sputnik Polynesia is rich in nitrogen, carbon monoxide, and methane. Ice, the close-up photos of the ice plain demonstrate that the frozen-out mass has moved over time, much like terrestrial glaciers do. The cold surface temperatures allow these frozen-out materials to move as though by magic, creating fascinating landscapes. The following image is a result of the sophisticated technical equipment's ability to take a photographic look back after New Horizons completed its closest approach to Pluto. As you can see, the captured landscape is bursting with detail from a distance of approximately 11,000 miles. On the left edge of the image, we can see a rugged mountain plain. The Norgay months are already briefly mentioned. If we now allow our gaze to wander toward the horizon, we can see the Hillary months, these massives towering up to nearly 11,500 feet above the landscape, as well as the impressive dimensions of Sputnik Laniakea. The icy plain in the Tombo Regio covers an area of approximately 650 by 500 miles above these oddly familiar-looking formations, and the thin atmosphere of the dwarf planet becomes invisible. The so-called Allergies month's rugged highlands, which are primarily made of frozen nitrogen, are on the left, and Sputnik Planitia welcomes us once more on the right. This high-resolution image demonstrates how unusually sharp the subdivision of the individual structures can occasionally be. The reason why the individual planes are divided into different segments and are adorned with numerous pits is still a mystery. Snakeskin terrain. From the expert's perspective, the following image initially seems to just depict an oddly shaped formation with a striking texture evocative of a snake's skin. Although the spectroscopic measurements of the region should raise some doubts among experts, the image may provide us with a much deeper understanding of the conditions of the protosolar nebula from which our solar system once emerged. It is located in the Tartarus Dorsa region. An elevation model developed by New Horizons indicates that the snakeskin formations are approximately 1,600 feet high. At the same time, we are dealing with some of Pluto's most steeply rising structures. Given Pluto's gravity and surface temperatures, the scientists questioned whether pure methane ice could sustain such steep formations over extended geological periods. The data showed that the area in question is primarily composed of methane with a small amount of water. Perhaps the most telling response is that the few research done in this area thus far presents entirely different images. One explanation is predicated on the observation that methane hydrate makes up the snakeskin landscape. While the sun hides behind the remote astronomical world, plunging its backside into impenetrable darkness, we can see a crushing-shaped area on the upper part of the celestial body showing us the shadowy landscape formations. Other studies strongly suggest that this ice-like substance already formed in the interstellar medium before it eventually became part of the solar nebula. In other words, methane hydrate may be among the oldest materials in the solar system. In this faint view, the natural atmosphere is also plainly apparent as a multi-layered nebula complex. New Horizons was roughly 12,000 miles away from Pluto at the time of the photo. Now, as always, share your thoughts, suggestions, and feedback about today's video in the comments section below. If you're looking for more fascinating contributions on the subject of space, check out our other videos, which you can view by clicking on one of the images in the credits. We appreciate your attention. Be careful, and we'll talk to you soon.